Good day, everyone. Welcome to That Friendly Writers Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about populations, parameters, samples, and statistics. In this video, we will introduce ourselves with more terminologies that we will soon use in the context of statistics and data analysis. All right, let's get started. Here's an example. Four talented high school students are applying for a college foreign exchange study program. Assuming that this is a population of their ages, Lucky is 15 years old, Maria is 12, Roy is 9, and Noel is 12. When we talk about a population, we are referring to a completed list of all subjects in a study. That means these four high school students are all and the only that share the characteristic of a high school student going abroad for study. So the population size is uppercase n equals 4, since there are 4 of them, and the population mean mu is 12, which we know how to compute by now. We have to understand that mu is a constant because these 4 students will not change at all. We call these numerical descriptors about the population as parameters. Therefore, mu is an example of a parameter. Another example is sigma, which is the population standard deviation, which we will not emphasize in this video. But what if we take only samples from this list? A sample is a smaller group taken from the population. Now, we must understand that within a population, there are many samples that we can take. Let's have three such samples. Sample 1 is Maria, Noel, and Lucky. Sample 2 is Roy and Lucky. Sample 3 is Lucky only. Let's show their sample sizes. Sample 1 has a size of small n equals 3. Sample 2 has a size small n equals 2, while sample 3 has size small n equals 1. Let us now get their sample means, called x bars. If mu is a population parameter, then we call x bar as a sample statistic. This is considered as an estimate for the true mean mu. The process of getting x bar is the same as mu. Pause this video to find out among yourselves how the first sample has an x bar of 13, the second sample has an x bar of 12, and the third sample has an x bar of 15. Each sample has its corresponding statistics. Because the sample mean x bar varies in values, we can also consider the sample mean x bar as a random variable itself as well. How about the sampling error of a statistic? Error is the difference between a statistic and a true parameter. In sample 1, the sample mean estimates a mean of 13, but the population mean is actually 12. Therefore, there is a difference of 13 minus 12 equals 1. In the second sample, both estimate and true value are 12, so 12 minus 12 is 0. Therefore, there is no error between our estimate and the true value. While the third sample has a sampling error of 3. So, which among the three samples produced the best estimate? It is the second sample because it has zero error in it, the lowest. We are lucky enough to have a sample that has no error when compared to the population. But most of the time, we cannot be this lucky since real populations consists of many values. In this case, we are looking for the one with the lowest error. There we go. This is how we give sample sizes, sample means, and their respective sampling errors. Let's have a summary of what we've discussed so far. Number 1, the entire group of all subjects that we want to study a specific random variable. This is called the population. Second, the numerical characteristics of a population, such as mu and sigma, considered as true values. This is called parameters. Third, the small group that contains some subjects that we want to study a specific random variable. This is called a sample. Fourth, numerical characteristics of a sample such as x bar and standard deviation, considered as estimates. These are called sample statistics. And lastly, number 5, the difference between the true value and its estimate, called the sampling error. There you go, our new terminologies that we will encounter. Now, for your practice, try to answer the following. Five children with special needs are given a math test. As expected, all of them got low scores because of their nature. Josh got 4, Peter 2, Ali had 8, Leo had 6, while Faith got 10. Determine first their true population mean score mu. Afterwards, give the sample mean x bar and their respective errors for each of the following samples with size small n equals 4. Which of the following samples had the lowest sampling error? Alright, this concludes our video for today. Hope you learned something new. Have a friendly day!